Hi, welcome. As I mentioned, Paul Magder graduated from Radio College of Canada as an electronics technologist. Paul worked in manufacturing for 20 years in the electronics industry. He retired as the Director of Operations in 2015. In 2013, Paul co-founded Repair Cafe Toronto and is a fixer servicing small home appliances, electronics, computers, cell phones, and mentoring apprentices. He has created and presented many workshops about repairing and basic electrical and electronics history. Welcome, Paul.
Hi, thank you. So welcome everybody to this workshop today. We're going to be talking about troubleshooting, and just to give you a little more feel about what the Repair Cafe is, in case some of you have never been to one. We're a group of volunteers who love to fix broken things. And before the pandemic, we would have events in libraries and community centers, inviting people to bring their broken things, and volunteers would work together with the person to help them figure out what's wrong with it and how to fix it, hopefully. And we also had an apprenticeship program where we would invite people who want to learn how to fix to join us, and they would work side by side with a more experienced fixer. And as a result of that, we had people asking if they could learn more in a more formal setting, because it's very busy and there's hustle and bustle at an event, and it's hard to kind of talk about things in detail. So we developed these workshops, and one of the types of workshops that is very popular is the one we're going to do today, called Troubleshooting. I'm just going to share my screen now with you guys, and then we can start the process. So today we're going to talk about troubleshooting, and it's all electrical that I'm focusing on today. You can, we fix other types of things. We do sewing and bookbinding and bikes, but today we're focused on just electrical problems. And so, yeah, so I always start with this little slide, because when our kids were little, and I'm sure you're going to come across this when you're fixing things, people would come over and they'd say, my this or that's not working, it's broken. I remember our kids used to run upstairs and say, the TV's broken, it's not working. And then go down and have a look, and well, actually you forgot to turn it on, or you forgot to plug it in. So there's a lot more to something when it stops working, and what we want to do is find out exactly what's wrong with it. So today we're going to I'm going to present a guide through which you can go through the process of troubleshooting. It's very straightforward, very logical. There's no real mystery about it. It's just something you need to practice and figure out how to apply to all kinds of different problems. And then we'll talk a little bit about electricity. You have to know something about electricity, even if you don't need to know the physics of it, but you have to understand the basics. So we'll talk about that and talk about tools that you need to use. And then, of course, we'll talk about safety, actually probably all through it at different points. And then finally, if we have time, I can demonstrate, how to apply this to a real item. But the idea here too is that you would have something that you want to fix, that you can practice on how to figure out what's wrong with it. So maybe in the next session, if you have something that you want to try out, you can present it and go through the process of how you would figure it out. So we'll leave that for the second session. So first of all, what is troubleshooting? Anybody? Okay, I'll just say it's basically a form of problem solving. And in this case, we're applying it to repairing products or processes. But let me just say that troubleshooting and problem solving is something that you can use for a wide variety of applications, not just to fix broken things or broken electrical things. You can use this form of thinking in all ways in your life. There's all kinds of problems that you come across, and the skills of troubleshooting can be applied to many of them. So it's not just about fixing electrical appliances. The official Wikipedia definition for troubleshooting is this: it's a logical, systematic process to find the source of a problem. And then you go ahead from there. Once you know the problem, then you can go ahead and try and fix the problem. So troubleshooting for us is not just finding out what the problem is, but then figuring out what to do next and how to fix it. So, logical process. There's a step-by-step way to do it. The first is to clearly describe the problem in detail. And that's what I was referring to with my kids running down saying the TV's broken. People come and they just say it doesn't work, and that's not good enough. You have to actually know in detail what is the problem. So again, for electrical appliances, is it completely dead? There's nothing happening when you plug it in and turn it on? Does it kind of work? Are there flashing lights? Are there no sound, and so on? And so you've got to go through and see exactly what the problem is. Then the other thing you have to do is understand a bit about what the thing is you're fixing, how it works. And again, not in total, not deep down detail, but just generally look at it and see if you can create a block diagram in your head or even on paper. How does this thing work? What are the chunks that go together? And what does it output? What is the input? And then when you're doing the actual troubleshooting, now you understand the problem. You get a sense of how the thing works. You go step by step in a process of elimination. And we'll go through all these things in more detail. So already, safety first. This is very important. You know, electricity is dangerous. It's something you can't see, so you don't know where it is sometimes. You're not sure where it is. So you have to always be very careful. And I always say, look before you fix. So look at the item, make sure you know how it's powered. Sometimes it may be batteries, sometimes for computers, they have adapters, sometimes it just plugs in. What kind of power is it using? Now, when you're actually taking things apart, you have to think about protecting yourself and also protecting people around you, especially if we're doing a repair event, if you're ever working with other people. One of the most dangerous things when you're taking something apart is not electrical, it's mechanical. Springs. Springs come flying out of things all the time. So you have to know that there might be something that could be dangerous. So cover your eyes and protect your hands if necessary, and also keep a clear space around you and warn people when you're doing something. There's dangerous materials, again, not necessarily electrical, but part of electrical products. We've come across what we thought was asbestos one time when we were in a repair event, and it was kind of scary because if it had started to blow around in the air when we opened this thing, it's very dangerous. So we don't actually fix anything that uses heat, like a hair dryer or a heater that is older than 1994. We found out that's when they stopped using asbestos. So sometimes it's good when you think something's old just to check you know, you can look up the model number and see how old this item is. Lately, I haven't really come across things that old, except for maybe tube radios or tube televisions or something like that. But anyway, asbestos is something you want to keep away from. There's chemicals you have to watch out for, and also compressed gas. So sometimes people bring in dehumidifiers, air conditioners. We don't really do refrigerators, but they have the same technology, which is using compressed gas. So we don't touch that. We don't work with compressed gas. You actually have to be licensed to, you know, fix a refrigerator or an air conditioner. Chemicals, well, you'll come across grease and oil. You know, it's good to wear gloves. Even sometimes you don't know. Gasoline, we fix weed whackers and lawnmowers. So again, it's a matter of just being aware of what you're working with, understanding how it works and what's involved with it. Of course, with electricity, the big thing is avoid working with equipment that's plugged in. So if you're opening up anything, you're taking anything apart, it has to be unplugged. And the only time that you have something open where you need to give power to it is when you're making a measurement or you're doing some kind of live testing. But then we'll talk about how you go about doing that. You have to be very careful, but it is necessary sometimes. Of course, it's, you know, if something's battery operated, it's not as dangerous, but it's just a good habit to always be careful, always turn off, take out the batteries before you start taking things apart. And be aware of your surroundings and be aware of how everything is connected, so that you don't accidentally do something, which I have done, I have to confess. There's occasions where I was very overwhelmed. There were tons of people, lots of action, and I unmistakably connected things that shouldn't be connected. And I blew a breaker and half the room shut down. And the other thing that happens sometimes is there's a lot of things plugged in at one time. So I think I plugged my test item in and I turn it on, nothing happens after I tried fixing it. Sorry, that's my phone. It'll go. I try not to have too many things going on at one time is what I'm saying, because not only have I done it where I thought it was plugged in, but I've done it where I thought it wasn't plugged in. So you just got to be careful. All right, so what we're going to do now is go through that process that I was talking about, and I'm going to use this fan that I found on the side of the road one day as an example. So the fan, first of all, I found this fan and I brought it home and it wasn't working. Mostly, well, the first thing, there was no power cord. Somebody had cut it off. So I did have to reconnect, put a new power cord in. Once I did that, I looked at how does this fan work. So it has 4 buttons, and the first button is an on-off button. So that's this, I don't know if you can see, there's a white button here. Then they have 3 other buttons. It had 3 other buttons, and those are the 3 speeds. Most fans have multiple speeds, so you can blow soft or medium or hard. Now, when I turned it on, only the slow speed was working. So I tried all the other buttons. The on-off button worked, the slow button worked, but nothing else worked. So there's the problem right there. You say this fan doesn't work. Well, it does kind of work. It works partially. So what is wrong with it exactly? So now describe the problem. This is just so, that was a specific example. So what are you doing? When you're describing the problem, you're asking for the symptoms and what is the indication that it's not working. When does the failure happen? Is it during operation? Is it not working at all? Is it after a while? Sometimes things work and then they stop working. And often you have to ask these questions. If somebody brings in something to be fixed, you may not be able to see it right then and there. So you have to kind of interrogate the person. Is there overheating of any part? Sometimes a fan will be trying to turn and it's getting hot, but it's not working. Or you might find a laptop, for instance, gets really warm on the bottom when it may be sort of on, but it's not, and you touch the bottom and it's quite warm. Phones get like that too. Are there funny sounds? This is a common way of figuring out what's wrong with something. Sometimes they beep on purpose. Some things, electronic things, actually have error codes based on the number of beeps. Are there unusual sequences of lights or indicators? Again, same thing. Coffee makers with all the different dials can flash funny different ways. It's really good to get the user manual. And when people bring things in to be fixed, we ask them, bring your user manual. Because there's a lot of gizmos and gadgets on things that people never use and they don't realize what they're doing or what they're for. And there are, again, as I said, error messages. This can be found out sometimes if you go online, you put in the model number, and some things will actually tell you. They don't have it in the manual, but they'll have it on their website, or someone else has figured it out, what the error, flashing lights, like TVs, sometimes when you go to turn them on, they don't turn on, but the remote receiver will flash 6 times. That means something. If it flashes 8 times, it means something. So these are all these little details that you can use to figure out what's wrong. And then, of course, this is what is the most important, is to reproduce the problem. So someone comes and says, there's a problem with this. It's, show me. I want to see exactly what's going on. Now, if you're fixing your own thing, of course, you'll have all this knowledge as already, but even your own items that you're trying to fix, sometimes there'll be an error message that you didn't realize you have, or you didn't read the manual. Most people don't. So check the manual and see if there's anything. Sometimes manuals actually have a troubleshooting section in them. So they try to help you. Okay, so back to the fan. The fan, now we're going to do a block diagram. So we know the problem. Now, how does a fan work? Okay, the first thing about a fan, and most things, is it needs power. Most electrical things need power of some kind. In this case, it's a power cord that plugs into the wall. The next thing is a switch. So your power is coming in and it's going through a switch. The switch is controlling the flow of current. And most things have a switch of some kind. All electrical things should have a switch. You need to be able to turn off the flow of electricity. Sometimes the switches aren't that obvious. In this case, the switch is controlling the current flowing to a motor. So a fan is made up of has an electrical motor, and then the motor is connected to the fan blades. It's converting electrical energy into mechanical energy. So those are the 4 sections of a fan. 3 of them are electrical and 1 is mechanical. Now we understand how a fan works. So the next thing, I already checked the cord, obviously, because I put a new one on. So I know there's power getting to it. So what did I find? So I could, once I knew the power cord was good, I opened up the fan, and this is the tower. This is where the switch is that I was showing you in the other picture. I took off the blade, so this is the connection to the blade. Here's the motor, and this is the connection wire to the motor. So first step, power cord, done that. Next step, check the switch. Okay, now you see I'm checking it as the electricity is flowing into the product. So one, first the power cord, then the switch, then the motor, then the blade. So I found that the bracket that holds the switch was actually broken, which I kind of thought, because when I was pushing the buttons, the whole thing was moving back and forth. So then when I thought, okay, maybe the switch is broken. But when I tested the switch with a multimeter, which we'll talk about later, I found out that the switch was good. There was nothing wrong with the switch. And here you can see the switch. It's hard to see. The buttons are here, and each button changes the connections between the power coming in and the fan motor. So these wires are going up to here. So the next thing I did was look at the motor, and I don't know if you can see here, I found that the wires were broken. Two of the 4 wires were broken, or actually burnt. So then I thought, okay, that seems like an obvious problem. And I followed back. One of these wires is for the return current, and we'll talk a little bit about circuits later. And then one wire is for the slow speed, and the 2 other wires were for the middle, medium, and fast speed. I reconnected the wires, and the fan worked. So I didn't have to go any further. I didn't change anything. I just changed the wire connections. That's the only thing I did, and I was lucky that it turned out to be the problem. I mean, it seems obvious, but it may be there's more than one problem. In these fans, they often have a fuse inside the motor. So it could have been that whatever caused the wire to burn up also blew the fuse inside the motor. So even though I was lucky this time, sometimes you'll fix one thing and it turns out there's still something wrong. So at least you're getting there, but you've eliminated one problem. So that's the basic process of troubleshooting. You go through and you step by step, you follow the process, and then when you find a problem, just fix one problem at a time. Okay. Oops. So as I said, we do one thing at a time, and the other thing is, I know I was saying I'm following through the block diagram, but also you can check obvious things first. And also sometimes it's hard to take things apart. So if you can check the outside things before you open it up, it's better. And of course, I've done this, I can't tell you too many times, where I wasn't following my own process. So I got something to fix, plug it in, it doesn't turn on. Oh, well, it must be, there's a fuse. I open the whole thing up, I find the fuse is good. Then I look a little more carefully at the power cord, and I realize that one of the wires is broken right at the cord. That should have been the first thing I checked. Don't open up the whole thing if you don't have to. So always start with the easy stuff first, if it makes sense, and then go deeper and deeper into it. And that's why I say, is it plugged in? Because I'm not kidding you. It's happened many times that something doesn't work and they find out it's not plugged in. Okay, and then of course, follow the flow. Don't skip steps, which is, I've learned the hard way. Or make assumptions. Again, I thought, oh, it must be the fuse, So try again to make only one change at a time when you're testing, not just, sometimes it's not a matter of taking it apart, but you have to do some testing. So just test one thing at a time and then check, did this help? Did it not? Like sometimes it's in computers, you're fixing some software, just change one thing and then run it. Does it work? Don't change more than one thing at a time, otherwise you don't know what was wrong. All right, so then we get to another equally difficult part about fixing electrical things, and that's taking them apart. And as you know, probably, manufacturers do not like it when people take their stuff apart. And they make it more and more difficult, as they've made it more difficult over time. And we'll talk about some of these difficulties. But assuming that you have something that's pretty obvious, that has the screws are visible, use an egg carton or an ice cube tray. As you're taking out the screws, put them in the ice cube tray in order. So you start with, okay, maybe there's 4 screws holding the bottom on. Put those 4 screws in one cube. Then you open it and you find there's more screws holding something else, like the power cord has something holding the wire in place. Next cube. And so you go in a particular order. So when you're putting it all back together, you go backwards and you go, and you know, okay, I've got 4 screws for this part, so there must be 4 holes somewhere, you know, that I need to fill those 4 holes, because sometimes it's not obvious when you're putting one component inside another. You can't always see everything and you might forget to put a screw in. So when you get to the end, you shouldn't have anything left in your ice cube tray. If you do, it's like the surgeon who forgot the scalpel inside the patient. Oh my God, what happened? I've got this, well, it's the opposite, I guess. I've got a screw, where did it go? So it's very important. And, you know, even if it's a simple thing, again, you know, I've done this too many times. Oh, it's a simple thing. It's just a kettle, and I just throw all the parts in one container. And then when I'm putting it back together, it's, wait a minute. I don't remember. And then the other good thing nowadays is you can use your camera, your phone, and take pictures. And it's really good to take pictures as much as possible, because sometimes there's wiring that you're going to, you know, disconnect, and often they're color coded, but sometimes they're not. So you really need to remember what was connected to what. You can't put things in the wrong way, if, you know, unless, well, you're going to end up making things worse. So I used to draw things out. Now I use the camera. Okay, so the manufacturer's tricks. This is something you're going to learn as you go along. And it's kind of frustrating because you know that something's not working, but you can't get inside to find out the problem. So first thing they do is they hide screws. And I guess you guys, when you're doing, or some people were working on phones and laptops, they're very difficult often to figure out how to open up, because they like to make them look all smooth and classy. And so, as you can see in the picture down there, often they'll hide a screw under a foot, or in some cases, they'll hide it just under a plastic plug. You look at something and you don't see any screws anywhere, but you might notice a few little rings here and there. So you have to have the guts to dig out those rings. Sometimes it's plastic and they'll get a bit damaged, but very often they turn out to be not just a circle engraved in the plastic, but they're actually a plug that's pushed in. You pull it out and there's your screws underneath. So other things they do is they hide them under labels. And sometimes the label will say, warranty invalidated if this label is broken. Don't worry about that. that's a good sign to open that, scrape that label away, because probably there's a screw hidden underneath it. And you know, I do have to say, when people bring me things that are broken, and I ask them how old it is, because if it is under warranty, just made me think of this, usually I tell them to take it back and take it, you know, get it, use their warranty, because it's true. Those warranty stickers, actually, they have no legal validity. They can't really not fix something because you broke the label, but they'll give the person a hard time, and often people don't want to, you know, go to court over something like this. So if it's under warranty, use the warranty. That's what I always tell people. The other thing is, nowadays they have these weird screws. They don't, and I don't know if you're familiar with the different names for screwdrivers. You've got your, obviously, your slotted screwdriver, which was what everybody knows from childhood, but then there's Phillips, there's Robertson. Those are the common screws. We used to have a little contest at some of our events, name the screwdriver. And I don't know if you know, but Robertson, which is the square one, which is way better than the Phillips, which is the cross, because they don't wear out, you know, when you're forcing something. Anyway, that's a Canadian design screwdriver, just in case you didn't know. So you don't find them in the States. They don't use them. Anyway, so there's really a lot of strange screws that people use nowadays. They're called security bits. They claim it's to prevent people from, you know, hurting themselves. Like if your microwaves always have them, kettles have them, things use heat. But you know, even also phones use them. They don't want you to fix your phone. And sometimes laptops, the newer laptops have them, newer computers. So I've got some pictures I'll show you in a minute. And then there are things that actually don't have screws. They are plastic cases and they're snapped together. And that means what you have to do is take your flathead screwdriver, find the seam, stick your screwdriver in and twist. And it's scary because it's plastic. Usually these are always plastic cases and they can break. And in fact, sometimes they're made to break, those clips. I just opened the bottom of a coffee grinder the other day. It was snap-on at the bottom and all the clips broke. You can't not break them. It's the way it's designed. But I just taped it back up so it was still usable. But anyway, and there are things that are glued, and if it's glued, actually phones, you know, the glass that everybody breaks, a lot of them are glued on, but they can be taken off and re-glued. It's the worst case scenario. Gluing means that the thing that is very, very inexpensive, and they spent no money on manufacturing. Okay, so as I said, you know, we can find the screws, security bits, I'll show you in a minute, and look for the seams. And oh, the other thing I forgot to mention is YouTube is amazing. You won't believe how many people go to the trouble, and I've tried, I don't know if you people have made videos. It's not easy to make a video, I don't find anyway. The lighting and getting up close, but there's amazing videos on YouTube of fixing almost anything you can imagine. You put in the model number and the manufacturer name, 75 to 80% of the time you'll find a YouTube video of someone showing you how to fix it or how to take it apart. So just, I mean, and then the other thing is there's a website called iFixit, which is an amazing organization, American organization. They have repair guides on their website, free. And they started off with phones and computers, laptops, But it's every make of iPhone, every make of MacBook. The Apple ones are always the hardest, but then they expand. They have all kinds of things they even have cars on there. So the way they make their money is they sell the tools, but they are amazing. And they're also fighting for the right to repair. They're one of the leaders in the United States, the fight to force manufacturers to let us repair our own things once we buy them. Who owns it? We own it, but yet Apple doesn't let you fix it. Okay, so the other thing you can do, because you may not understand how the thing works, this is, that's the great thing about fixing stuff. You're learning all the time. And so you learn from taking things apart, but sometimes you might take it apart, but it's not obvious how it actually works. So it's often you can find these explanations of how things work, or in this case, if you want to know all the parts or make a block diagram and see what the components are, you can find a lot of times, or sometimes manufacturers will have exploded pictures of their items. I don't think it's so much anymore, but if you have older things you're fixing, often you'll find an exploded picture. So with a kettle, you've got a power cord, you've got a switch, you have a light, heating element, and then you've got the mechanical parts which open and close the lid and where you place it to get power. So everything can be found out, and the more you learn, the better. Okay, so tools then. You need tools for opening and taking apart, tools for testing. You need good light, and you need, in my case, something often to help you see little things, magnifying glass, or some people use their phone. They can take a picture and then blow up the picture. So you need to be able to see as much as possible what's going on. Pen and paper, not so much anymore. Okay, here's an example of security bits. This one is called a snake eye, just 2 dots. Now you can actually make your own screwdriver for the snake eye. You take a flathead screwdriver and you file in the middle. You just file out the middle and you've got 2 points. So that was one of my first security screwdrivers I made. But after that, you've got to buy stuff. So here we have a Phillips screwdriver, but it has a pin in the middle. So you need a screwdriver that has a hole for that pin to go into. And this is a hex screw, and this is a torque screw, and they have 6 points. And both of those have pins. Triangle. Now I haven't ever, this one here I have come across. This is actually not possible to take out. It's only goes tight. It cannot loosen. You see how they've cut off the reverse screw part. So you cannot open this screwdriver, this screw. You have to actually cut it off or something. And then this one I've never seen, but I have a picture of, here's the toolkit. So you can buy these toolkits at Canadian Tire, and you can see they have all these different types of screw heads. And here is the one with the hole in the middle. See the holes? Those are for those screws that have a pin in the middle. And then you've got triangles, snake eyes. These are called torques. And often those are used on phones to keep you from opening up your phone. And we've got, in this case, the normal standard one. So there's different kits with different assortments. You want to make sure you get one that has snake eyes and triangles and with the holes for pins. They're very common, those ones, the Torx with a hole in it for microwaves. Okay, so the next thing we're going to talk about is testing. Of course, electricity is not something you can see. It's not like plumbing where you can see the leak or find a leak because there's water coming out. So we need to be able to test electricity. And again, as I said before, you test every time you change something. So you might not need to use a meter. You might just say, well, I did this, plug it in, turn it on, see if it worked. Unplug it, do something else, plug it in, see if it works. So it's, don't take any shortcuts. It's a slow, gradual process. And as I say, turn off and on the equipment. This is another safety check here. Do not operate, change something, do not fix something when it's plugged in, or even if it has a battery. Take out the battery, do something, put the battery in, test it. So for using electrical meters or digital multimeters, I'll talk about that. They're good for all kinds of, I'll show you what they're good for. They're important to understand how to use. And also, this is something that maybe more complicated items is have a test plan so that you know what you're going to do step by step, especially if it's something, a little more dangerous. By the way, I don't know if you've ever come across the old TVs or old monitors, they're called CRTs, cathode ray tube displays. Do not fix those. And we'll talk about why later on. You don't open them. They're very dangerous inside. Okay, so here's a multimeter. And it's called a multimeter because it can measure all kinds of different things. It can measure voltage and current. So we'll talk about those things in a minute. AC and DC, both voltage and current. It can measure resistance. Some of them can measure capacitance, which is another kind of item that causes failures, and diodes and all kinds of different components. But sometimes basically a very inexpensive one will measure voltage, current, and resistance. And those are really the only most important things that you need to be able to measure. Even resistance is something that, not so much the resistance, but it's a way of checking if you have a broken wire. So basically, a multimeter has a dial that can change what you're going to measure. It has two probes, which plug in to the meter, and it depends what you're measuring, the way they plug in. Black is always the return, the ground, or neutral if it's AC, and usually that's always in the same place. And then the red is for the live side, and you'll move that around depending on what you're measuring. The display is, you have to understand about units of measurements, and that's, kilo ohms, mega ohms, microfarads, milli. So this is going to show you down to the 3 zeros, one way or the other, what the value is. So it should, often they'll change ranges, or you have to manually change the range. And when you're testing voltage, especially, and this is something, get in the habit, no matter what you're measuring, always start at the highest range. So say you're measuring the power coming out of your wall, you know it's 120, but usually they have the highest level is 600 volts. So start at 600 volts. And if you can't read it, like it's 0.0001 or something, then turn it down to 200 volts and see if it shows you a reasonable number. Always start at the highest value, and that way you won't damage anything. Okay, so probably I just said this. Okay, so just review for some of you may not know the different terms. So V is for voltage, and R is for resistance, and I is for current. This is when you're looking at calculations. But the units of measurement for voltage is volts. For resistance is ohms. That's the unit of measurement. And for current is amps. Now, voltage is the force that pushes the electrons. So electricity is named after electrons. Electrons, as you all know, are part of the atom, and they move around on the nucleus of the atom. Those electrons can be knocked off, and this is theory that if you want to take the course, the following course that Andre is going to do, he's going to go into much more detail about electricity, how it works. But basically, electrons get kicked off the atom, and they go bump to another atom, and then that electron kicks another electron, kicks another electron, kicks another electron. So it's a flow. It's not really one electron moving, it's a bang, 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 bang kind of process. And that's the flow of electricity. So current is the flow of electricity, but how do you kick those electrons? You need a force, and that's what voltage is. It's the force that's knocking off those electrons. And you have two different kinds of voltage, DC, which is battery generally, or things that plug into your laptop or your phone are adapters that convert AC to DC. So they're not, the thing that charges your battery, it's putting a DC voltage into your phone or your laptop, but it's got something there like those little blocks that plug into your power bar. Those are converting AC to DC. And then AC is a wave, alternating current. So DC stands for direct current, and AC stands for alternating current. And this is what they look like if you were to look using an oscilloscope, which visualizes the electrical current. A battery or direct current is always just flat. It's, say this is 5 volts, it's always 5 volts. AC is alternating. Say it's going from positive 5 volts to negative 5 volts, positive, negative, positive, negative. It's a sine wave. And that's, there's a whole reason for having the two different voltages, which again, Andre will talk about in detail. Okay, so current, and current uses the letter I because it's from the French intensité, which means intensity of current. And some reason, I guess a lot of Ampere, the person named whose name we use for amps for the unit, he was French. So a lot of French scientists discovered and developed theories of electricity. Anyway, current is the rate of which the electrons flow. So you have a certain number of electrons and a certain speed at which they're moving based on the force of the voltage, and also the size, the amount of material that the electron, the atom, the number of atoms. So copper, for instance, is the common material used to make electricity with. So if it's a big thick bar like this, you'll have a lot of electrons moving. If it's a little skinny wire, not so many. So the physical size of the wire and the amount of force is how you create different rates of flow of current. And again, current is AC or DC, the same as voltage. So electrons are moving actually back and forth like this when you have AC electricity, because it's changing polarity all the time. And you know electrons are attracted and repelled from positive to negative. So when you have AC voltage, it's actually going back and forth like this. And DC, it just goes straight. So then there's resistance. So resistance is the ability to resist the flow of current. And this is how you actually control the flow of electricity, because you can control it with voltage, but it's very crude. It's like fast or slow, basically. It doesn't have a lot of finesse. But when you get into electronics, you need to be able to do a lot more controlling of how the current is being used. And so resistors are important to manage that flow. And they're based on the type of material that they're made out of. So the interesting thing about resistors is a light bulb is basically a resistor, but the wire that goes, called the filament, is specially designed so when the current flows, it resists, and when it resists, it creates light. It glows. A heater is a resistor. When it's designed so that when it also glows, but it glows in such intensity that it gives off heat. I mean, light bulbs give off heat too, but not the same way. And then a motor is actually not a resistor. So it's working on a totally different concept or physics of electricity. So some things are just straightforward resistors, and other things are, using different facets of the physics. So the reason I'm talking about these things is because these are the things that you can pretty easily check. And I'm just going to give you this one formula, which you just have to know, because just in terms of the relationship between these three things, because these three things are the basic building blocks of electronics and electrical circuits. The other thing I forgot to mention is it's called an electrical circuit because it's a circle, and always you have to have a return path for the electrons. The reason the voltage force is pushing electrons by being negative on one side, it forces the electrons, which are negatively charged components, and it's attracted to the positive side. So that's the only way that they'll actually move. They move around in a circuit. So obviously, if there's a break in the circle, then you're not going to have whatever it is you need to be working. But you have to be aware that there's always got to be a return wire. So that's why your plug in the wall always has two wires. One's to go out, one's to come back. So everything's going out and coming back all over the city, all over the world, wherever there's electricity flowing. It's a big, huge circle of life. Okay, so anyway, just briefly, current, this is called Ohm's law. Ohm was I think he was German. He discovered this relationship, a very important scientist. So the relationship between current, voltage, and resistance is the current equals the voltage divided by the resistance. So when you're designing a circuit, you know that if you put this amount of resistance in, it's going to change the flow of the current, and it's going to change the flow of the amount of force that's required. So that's just the basic relationship, but all kinds of other design features can come out of this. And that's for another day. But what we're going to do mostly with that meter is measure voltage. So we need to know if the voltage is AC or DC. And then we're going to measure resistance. And usually we're measuring resistance not to get a value so much as to find out, is this wire broken? Because if the wire's broken, you'll get infinite resistance. And if it's not, you'll get what they call continuity. And there's actually a measurement called continuity. And most meters have a little beeper. So when you have continuity, you get a beep. And then you know that's good. You want to hear the beep. So that's one of the basic measurements that you'll make when you're testing a wire to see if it's broken, for instance. You'll measure two ends of the wire. If you get a beep, you're okay. And the reason we may or may not calculate current, which I guess you can't quite see here, is because current is more difficult to measure. And it's also more dangerous. And so we don't usually measure current, but sometimes you have to know what the current is to figure out how much the value of a fuse, for instance, or how much power, how much demand your item is asking for. So current, when you plug in something, it has a circuit, and that circuit needs a certain amount of current, needs a certain number of electrons to flow through it. And it demands that from your wall. And so if it's too much, then something's going to blow up. So you have to make sure that you know how much current, in some cases, not always. Most things, it's not that critical, but if you're trying to figure out some protective component of a circuit, you need to know current. All right, so we basically talked about this already. You need to measure voltage to see if something's working, measure resistance to see if a wire's broken. Now we'll just do another safety check, measuring voltage. Now, I said before, sometimes you have to have the power on in order to test it. It's, you made a change, you've connected something, and you've got it all apart, and you don't want to put it all back together, plug it in, find out it's still not working. So you want to test it while it's open, or while the piece is disassembled. Very often, even though the cover, all the plastic, all the casing's off, the circuit's still there, it's still functional, it just doesn't have its protective cover. So what you do is you need to find a way to connect your probes. And just a reminder, 120 volts coming out of the wall is very dangerous. It's not, it can hurt you badly. Some people can be killed by it. So you're never going to be touching two parts of a plug that are plugged into power. Then you become part of the circuit. Your body becomes a resistor. And your heart is not made to be resisting that amount of current forcing through your body. So be very, very, very careful when you're using 120 volts. And what we do is, never allow the two parts. As I said, there's a wire coming in from the wall and it goes back into the wall. And if you connect those two together, it creates a circuit with no resistance, and it'll blow a fuse. Luckily, we have all kinds of safety measures in our house to prevent. Basically, what will happen if you didn't have a fuse, it would probably start a fire, because when you get a lot of electricity, imagine a lightning bolt hits the tree, it goes on fire. So there's protection for your house and for the street, for the transformers. But that's what happens when you connect those two together, like so. You don't do that. And also, if you're using a screwdriver and you're probing around, if you had forgot to unplug something, you could short, doing the same thing as putting those wires together. Just in case, even if it's unplugged, make sure your screwdriver has a plastic handle. Never use any kind of metal, never touch metal when you're probing or even when you're unscrewing things. Your screwdrivers, your pliers, everything needs to be insulated. So always use tools that have rubber or plastic handles. And as I said, never hold two ends of the thing together. Okay, so now let me just see something here. Okay, so what happens is when you're going to measure something, like this is a power supply. So there's 100 over here, there'd be 120 volts coming in. And this is what might be inside the box that is the thing that you plug into your computer. You know, one side goes to the wall, the other side is a wire going into your computer. In that box, this is what you might find. So you want to test this. Maybe you need to find out if there's a broken wire or if you're getting electricity. You might plug in the power cord here, and then you would, when you're ready, the next thing you would do is take, I don't know if, can you see my picture here?
You'll have to switch. Oh, there. Yeah.
That is a clip. It's an alligator clip, it's called. And what you do is you clip this on to where you want to make the measurement, and you plug the other end into your meter. So you never probing around with your hands, even with those probes, even though they have plastic, because things move around, you can slip and slide around. So always clipping things on. You make all your connections, you turn on your meter, you stand back, then you plug it in. You look at your meter, it shows you a measurement, you unplug your from the socket and go from there. So if you have to measure something live, that's what you're going to do. You have to use clips that mean your hands are not going to be anywhere near the item. And you're plugging in something, always use a power bar with a switch on it, because maybe you'll turn on the power and something will spark. You can turn it off right away. So it's a safety measurement. Sometimes your power bar has a automatic shutoff, but I never trust that. I use my finger on the switch. I turn it on and turn it off as quickly as possible. Okay, so that's basically the testing, and I just wanted to see what I'm doing here. Okay. Okay. All right, so this is just another component that we have to be careful of. I showed you that power supply. This is another one here, but one of the most common components in electronics, and they're in your computers, they're in your TVs, radios, even sometimes they'll be in humidifiers, dehumidifiers, I mean. They're called a capacitor. And a capacitor, again, Andre will go into more detail about how they work, but basically they're like a battery. They hold a charge, but they can be discharged and recharged, discharged and recharged. So the reason I was telling you about those old TVs, they have a big capacitor in them because you need a lot of voltage for that cathode ray gun. And it's like something like 1500 volts, some huge number. But the thing about capacitors is they hold the charge. They're like a battery. So if you were to accidentally touch the two ends of the capacitor together, it would suddenly discharge a lot of voltage, and that can be very dangerous. One of the other common dangers that people come across is camera flashes. And again, I don't think it's only if you're fixing an old style camera. They don't use them in phones anymore. They use LEDs now. But in the old days, they had, if you ever come across an older camera, not a digital camera, they would have a flash, and that was basically a capacitor charged up. And when you push the button, the flash would discharge through the light and make a flash. That actually can burn your finger. If you accidentally discharge that on your finger, you'll get a burn. That's how much current comes out of it. So particularly these types of capacitors here that look like a can, can be dangerous. So that's something you have to watch out for when you're opening up. And the way that you make it safe is by taking if it's a large one. The other one where, again, they don't make them anymore, but old microwaves, they use a big capacitor to get your high frequency, high voltage magnetron working. And the way that you protect yourself is you take a big screwdriver with a plastic handle or a rubber handle, and you put it across the two sides to discharge the capacitor. But again, that's not something that you're going to come across very likely. The new microwaves don't use that type of capacitor anymore. You're not going to open up an old tube TV, and they don't make cameras like that with flashes anymore. So just something to be aware of, that these can have some voltage and some current in them. So and capacitors are not that easy to measure, so we don't really measure them. Just to point out, see these, I don't know if you can see these capacitors here, they have like a bulge. They're kind of bulged, whereas these are flat. These are no good. So that's how we can tell if they're good or not. And often this is a problem with flat screen TVs. They get these failed capacitors. If you ever see one, you have to replace it. And amazingly enough, you can fix a TV by just replacing the capacitors on usually the power supply. Okay, so I think, let me just see. Oh, so something's going on with oh yeah, so this is just, we talked about a little bit, resources for you to get information, manuals, and also to find parts, YouTube videos, and so on. Okay, so let's go to the questions now.